So I'm just giving myself a quick refresher on vector mathematics. My understanding of this and is that if when we say a dot product, then it
Mhm.
is the first one with the first one. It's used to be first row and first column.
Yeah, so I mean, so yeah, so dot product. Okay, so in general, if you have vector v1, that's like a three-dimensional vector ABC, and if you have v2, by the way, the dimensions need to match, right? If v1 has three elements, then v2 should also have three elements. Then v1 dot v2 is going to be a times d plus b times e plus c times f. This is
Yes.
what a dot product is. Okay.
Okay. And finally, it's just one number. It's not a vector, right?
Yes, yes, just one number, a scalar.
Okay, got you. So A into D will be a B into E and C into F. Okay.
All right,
Uh,
so the main thing is that here the vector is going to be sparse.
yes.
Okay.
And that means that we are going to store the row and the column and the value in what maybe some kind of a structure like a dictionary or
Hold on. So okay, so row, column, and the value. What is the column here, and what is the row here?
this
I
one
mean,
doesn't
you're yeah.
have. So it's one dimension is enough. So it's the position and the value for non-zero values only. However, we
Okay.
have to account for the zeros when we are doing the product. So there has to be a quick way of finding out that there's a zero at the position so that when we multiply and add, it has to be accounted. Now what we can do is that dot product is the only, so in the constructor itself we can initialize our dictionary,
Okay.
and and when we are taking the other, so we have the this and the other. Now we are asking, so we can have an internal method called value, which will take away the complexity, which will basically do the work of looking into the other dictionary and finding out if it's a zero or a value and just returning the value. So whether sparse or not sparse is practically hidden behind the value.
Whether sparse or not sparse. I mean, both. Like when we're talking about the dot product of two vectors, we're assuming that both are sparse.
Yes.
So
So
yeah, so the dot product method and this vector argument is another sparse vector
correct,
object.
correct.
Yeah.
And that's the reason I'm proposing a private method called value, which will take an integer I, and it will give the ith value inside the vector, inside the this.
Okay. Sure. Sure.
And then the dot product is the simple mathematic that you just provided. It's we are basically multiplying the corresponding indices and adding them up, and the value method is taking care of the complexity of finding the ith value if it exists, otherwise it's returning zero.
Okay.
So
Sure.
yeah, so can I code it in these lines? So the key in this, as we discussed, is it's a single dimension. So we are just talking and one integer to mapping into another integer. So the key is an integer and the value is an integer, which we can call. Value is a reserved word, so let's make it just val. So sorry. Can I add another constructor? I don't know if that works because when so okay, it's a single. Oh, we are returning integer. Okay, yeah, then we're fine. What would we return if the vector that we are given is of a different dimensions than the one?
Well, that is something that you should have asked in the beginning, right? That's what I said. So, all those edge cases, hopefully, ideally are discussed in the beginning of the interview, not when you're like implementing it.
Mm.
But I mean, it's good that still like you realize that, about this issue, right? So, what do you want to do?
Well, in this problem, it says that they'll both be equal.
Well, yeah,
Right.
during a real interview, they will not give you all of those constraints.
Yeah. So yeah, otherwise they should definitely. We can throw an exception if that's not the case over here.
Okay.
So
Let's do that then.
actually, there's another issue. So this works differently in different languages. Whether you have access to the private members of the other class instances variables. Okay, so from the problem solving perspective, I'll make them both public right now. But
Mhm.
we don't have a result. We did not remember we know the dictionary, so we know the number of, but that's not really a full dimension. We never remembered the full dimension actually in this.
Right.
So we will have to save that. We'll have to make an int and save that thing.
Yeah.
Since we already wait, this is we can't use data. This dot val. If this is zero length, then what really happens? If the size is zero, then technically it can still be multiplied. Maybe they're both zero, and it's not really wrong. So
Well, I don't think that makes sense because like that wouldn't be a vector.
yeah, so some languages actually allow zero length vector. So
Well, that is in the computer science definition of vector, right? Here we're talking about like a mathematical vector.
yeah, okay. So let's disallow that. And what about max limit on this? So, and as far as an upper limit is concerned, should we have an upper limit
No, we don't care about that.
limited by memory? Okay. So what about negative numbers? It will have negative numbers, right? So even two,
Right.
so Yeah, it could have negative numbers, so this shouldn't be greater. This should be not equal to 0. So it's kind of an assumption here that it is really sparse, right? This can turn out to be, if it is not sparse, then we've just found a more inefficient representation. Otherwise, it wouldn't work because we're doing everything with the dictionary. So it contains nums
Hmm.
I. Hmm. But there's wait, where's the nums? This so this can't be nums. This is to be data. Okay, let's look at that example. So let's suppose we had 1, 2, 3.
That's fine. You can use Leetcode. Like you just need to be the one who's coming up with test cases. Like you can still use Leetcode
Okay.
to execute a code. That's fine.
Okay, I feel decent about the functionality of this. There's one thing which would work in some languages and not in others, so I did not do it. That was making making this private and these private will work in some languages in which the sense of private is specific to the type and not the instance. So let, let's. What is that? Dictionary. Oh, contains. Okay, contains key. Mm, okay, so I can do this. Oh, that's a lot of cases. So let's see. Hmm. Submit.
Well, so during the real interview,
Mhm.
any other test cases that you should try?
Yes, let me go up there. Mhm. So in this, the first one I would try is actually this. No, let me. Yeah, so one would be this and this. Then there would be. Let me list more systematically. To your first of all, let's just create with this and
Hmm.
try to do it against this. Then we should do one. And so the first one will not, is since we disallowed that case, that's not a
Hmm.
very interesting case. Now we should do this, and then we should do something in which the two, let's see if our exception
Yeah,
throws up, but
yeah.
it's an exception, so it's not functionally interesting. So now
Hmm.
let's make them sparse, which would be a good case to have. So make one of them sparse and make the other one not sparse. So also let's have numbers which is not just same numbers. So let's say 3 and 7, different numbers. So then
Well,
let's.
then this should still fail, right? Because they have different dimensions.
Oh, yeah, yeah. I meant to, yeah. So let's have more some numbers which are. mm, so this should be.
Okay, sure.
Then let's have one in which yeah, they are both complete, but they are not. So 3 and 4. So neither is sparse.
Okay, sure.
And
But
then
does your code really differentiate between sparse and non-sparse? I mean, we assume that the input is sparse. So
yes, the uh,
I mean, the code still works even if it's not sparse. So
it would just if there's any, although I think this part of the code is simple enough to for me to have confidence in it, but
Mm-hmm, mm-hmm.
well, it's code, so basically makes sure that the act of checking and putting into the dictionary is correct. If
Okay.
there's anything in the, yeah, I agree, it's kind of a
Okay.
trick. So the
Yeah.
other, I think the test case would all zeros. What about all zeros?
Mm-hmm.
So 000, even 3 will do. That's fine. So on one of them would be, if one of them is all zeros, and one being all zeros and is enough actually.
Mm-hmm. Okay.
And so the other case would be having, we already checked for the no zeros, we checked for all zeros, and so
Okay.
yeah, that's what I can
Good.
think.
Good. Okay. So now my question is, what would the runtime be?
We, while composing the thing, we took a single pass, and
Mm-hmm.
thereafter we every time we went into the dictionary every time. So it's full length, the uncompressed length of
Mm.
the vector, either vector, because they have the same size.
Yeah. 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 So okay. So the constructor, I mean, no matter what, you have to scan the
Yes.
nums, right? There's no way you can speed that up. But can we improve the time complexity of this dot product?
At any point, suppose, like, let me write this down a little bit. Suppose we, when we parsed the first vector, suppose we found a non-zero location at index 0, at index, say, at 5, at index 25, and at index, yeah, 68. Now, suppose we parsed the second, these are not values, these are the indices at which I found non-zero stuff. So
Mm-hmm.
in the second one, suppose I found something at 7, at 35, at 127, and at 200. And suppose both of them are actually 200 long.
Okay.
Well, let's make it 250. This is just because, okay. So, because the indice was 200 over there. So let's suppose they're about 250 long. Now, when I go about to multiply these, right now what I'm doing is I'm going to zeroth of this, zeroth of that, first of this, first of that.
Mm-hmm.
Now, if I was to go on the, instead of dictionary, if I used a sorted dictionary, and I knew right here that till the fifth, this everything is going to be zero anyways, because this one is zero. So it's like merge sort in some sense, because if I see that the first entry which is non-zero here is 5, and the first entry here which is going to be non-zero is 7, then till 7 we are going to get zeros. And over
Okay.
here, we are actually again going to get zero even on 7, because the first one, which is going to give us a non-zero value, is going to be one which is present, the indice value which is present here and here.
Mm-hmm.
So neither 25, neither 7 nor 25 nor 35 is going to give us anything
Mm-hmm.
non-zero.
Mm-hmm. So you want to
Unless,
find
yes.
things in common, right?
Yeah.
Common in this
If we had got
non-zero
a
indices.
127 here, then that 127 would be the
Yeah.
first one that would
Yeah.
actually give a non-zero value.
Yeah.
So
Okay.
the way to do that with what I have is that we already have dictionaries which capture the value.
Mm-hmm.
If I had,
Non-zero values.
yes, if I had kept track of the indices that gave us these values, which I did not, so in the constructor they had,
Well, your dictionary keys are the indices, right?
that's right, but the dictionary is not sorted, at least not now. We could either make that a sorted dictionary,
But
and
why do they need? Why does the dictionary need to be sorted?
because I need to, I will need to traverse it in the manner that I had done in the example to come to. Well, Actually, not really. If we are looking for one that is common to this and that, we could just, but we'd still need to go sequentially, because if just suppose there was a 127 and suppose there was 68 as well over here, then I want to actually, what happens if I go in the wrong order? We are only adding. So, well, I guess, yeah, the exercise then is to find all keys that are common to both the
Mm-hmm.
dictionaries
Mm-hmm.
and add their values and
Mm-hmm. Mm-hmm. Product
add
of the values. Yeah.
yeah, product their values. So so I could start with any one of these dictionaries, just go through all its keys and look for those keys in the other one.
Mm-hmm.
Yeah,
Right.
yeah, that makes complete sense.
Okay.
Can I go for it?
Yeah. Yeah.
Okay, so let me. So this is dot product. Let's. Should I? Can I? Or can I keep this in a private? Can I give it a try?
Okay. This makes sense. Yeah. Let's run it against the example test cases.
Yeah.
Okay. Good. Okay. So now my question is, can we on line 3? Can this data be private?
This depends on the language. Actually, I think
Now in C sharp.
my understanding is that it cannot be in,
But
in
can we?
Western
Okay,
languages.
if you make this private,
Mhm.
then yeah, on line 22, you wouldn't be able to do vec.data,
Exactly. So the
No,
concept,
right?
actually, it will work. It will work.
it'll work. And
Yeah.
so the concept, I think this was different between Java and C Sharp, and I don't remember which was which. So the idea of private
Yeah.
being specific to the type or being specific to the instance, I can give it a try right now, but to be honest, I don't
Mm-hmm.
remember.
It works
Okay,
in
that's
both C sharp and Java. Yeah. I mean, C sharp will basically clone from Java. At least 10 years ago, that's where it was.
okay. So okay, good, good. So is there any way that we can sort of hide this data from the user, this data field from the user?
It's currently hidden because it's private. So you mean,
But
uh,
can you make it so that they cannot access it?
is it currently not so? Because it's private, so anyone who's not this class will not be able to access it, right? Or you mean even hide it from the instance of any other instance, so
Yes,
that
from the instance. Yeah.
yeah.
I don't know. I'm not familiar with
Make
C
it
sharp, but
make it this thing, make it a property. So don't do it like this. Say do it like this. Get private set. But in that case, what will happen is that now you can somebody else can get it and he can't set it. If he but
So yeah,
somebody,
I feel like the users probably shouldn't be able to access this data directly. If they want to if they want to read the data, what they can do is they can use your val method, right? You have
yes,
a val method. So this val method should be the method that the users call to retrieve a value at a certain index.
correct. So
Right. So I think this val, it makes sense for the val to be private, to be public, actually.
mhm. Okay.
Right. But the data can, data can be private. Also, ideally, like the data shouldn't even be. I mean, depending on the use case, maybe we don't. I mean, we provide a modify methods for them to modify a particular index, but they probably shouldn't be able to manipulate this data dictionary directly.
That would be this. That would be providing get and private set methods.
I see. Okay. Yeah, this is good. Any comments from anyone?
Just a comment that in C# this is as hidden as it gets.
Oh, I see.
Yeah, the any way to make it even more hidden just goes into hacking obfuscation territory.
I see. So that the users cannot guess the field names, basically.
So
Well, they can guess, and actually C# just like Java in this regard, they are very open. You can take well, there are lots of tools on the market that allow you just to do memory dump and examine all the internals, including all these private fields, etc.
Oh, I see.
So you can do it on a Microsoft apps, on a system libraries. So there's no problem with doing that. It's almost like HTML developer tools in a browser.
I
Just
see.
little bit harder. If you want to protect against this, you need to do so-called code obfuscation, and those tools, they just make your code, your DLLs, unreadable by normal tools.
I see.
Unreadable. They rename variables to terrible names, like instead of
that
data.
don't work. So those obfuscators actually at the .NET level, if you have the .NET code, you when you use tools to reverse engineer from the .NET code level, they give you perfectly good logical names. I don't know how they are that good, but nowadays the tooling is so good that I think source code level privates and all that it doesn't have that much value.
I don't remember how good obfuscators are these days. I tried them like in 2008, and they were, well, at least for tools those days, the code after obfuscation was unreadable and unbearable. You need to spend years to try to understand what's happening. So probably it was deterrent enough to demotivate hackers from looking into your app. Today, I don't know. I have not tried those.
I see. Okay. Yeah, this is good. So previously you mentioned that maybe there's a way of solving it without using a dictionary, and you mentioned that this the process looks similar to a merge sort, right? Can you elaborate on that? Can we maybe solve it in a different way? Yeah, lines 56 and 57.
In this, so as the discovery was the we are looking for, even if we didn't have a dictionary, we just kept note of the non-zero positions, and we even maintain them in a list. we would actually find ourselves scanning each of these lists. These lists are naturally sorted because
Yeah.
it's increasing
Yeah.
order of indices.
Yeah.
And if we just scanned through these lists to find the first one where we met the same index, then we'd be in the same place.
Okay. Okay. So
So
can you do that example on in this case on lines
okay.
56 and 57?
So in this case, we can just neglect the blanks and
Yeah. Yeah.
uh,
Yeah.
keep these numbers are sequential. We see
Yeah.
we create two pointers. So in the first one, the pointer is here, and
Yeah.
in
Yeah.
the
Yeah.
bottom one, the pointer is here.
Okay.
Yeah. And yeah, so we see that 0 is definitely not equal to 7, and
Yeah.
0 is less than 7, so we move this one over here. And we see that
Okay.
that's the case. 5 is less than 7, so we move this to 25. Now we notice that
Mm-hmm.
7 is less than 25, so we move the
Mm-hmm.
7 to 35. And now we see that 25 is less than 35, so we move this to 68. And then
Mm-hmm.
we see that this one is less. We're always moving the lesser pointer, and
Mm-hmm.
this one comes to 68, and we see, wow,
So they
68 is equal to
match.
68. So then we add this to our total, which till now was 0. Now it has become 68. So this 0 changed to 68. Mm.
Well, it's
And
not really 68 though. 68 is the
yeah,
index.
yeah, actually, it's the value at 68. So we should say this actually.
Mm-hmm. Mm-hmm.
So value at 68, and after that we move any one of them. It doesn't matter, and we see that 68 is less than 127. So we move this to 127,
Mm-hmm.
and now this 68 changes to 68. Yeah, block bracket 68 plus 27.
Okay. Okay.
27, and and then we come to the end of the
Okay.
list.
Okay. Cool.
Yeah,
So you stop when one
yeah,
of the pointers reach the end.
yeah.
Okay.
Mhm.
That's good. So how are we going to store lines 58 and 59? Are you going to use an array to store that?
I'm suggesting a list because we want to be able to dynamically add, which is almost like arrays, because I think internally it's a very similar implementation, except that they are dynamically resizable.
Okay, sure, sure. So, and what is being stored on that in that list, in the two lists?
A non-zero indices.
Just the index or the values? What about the
Uh,
values?
if we so it's non-zero. It's actually a tuple.
Mm,
Do we
okay,
need the
okay.
do we need the yeah, we need the indice, otherwise we wouldn't have anything to compare with.
Yeah.
So this in the algorithm that I just described, we need the indice, and of course we need the value to be able
Mm-hmm,
to act the result. So we still need the tuple. Instead of
mm-hmm.
being a dictionary, however, it would be a list,
A tuple, a list of tuples.
list of tuples.
Yeah. Okay, that's good. And what would the runtime be for the dot product?
The runtime, because we are scanning over both the lists simultaneously, it would
Mm-hmm,
be order of non-zero indices in either
mm-hmm,
in
mm-hmm,
yeah in
mm-hmm.
the longer of would it be longer of the two lists or shorter of the two lists? Because if one of them had only 5 non-zeros and the other had 25 non-zero elements, we the we are looking for an equality, so it has to be in the shorter of the two lists. So it would be
Okay. Yeah.
order shorter of the two lists.
Yeah.
Yeah.
Okay. That's good. Yeah, that's another way of solving this one. Um, were there any comments or questions from anyone else?
The time complexity for the second solution, wouldn't it be length of both of the lists combined?
No,
The
because we are doing it simultaneously. So
yeah.
So Alex, you're saying that you think there should be O of the sum of the two lists, not O of the minimum of the two lists.
Yeah, and right now
Well,
I'm not sure how to justify it. It's just it depends not only on the size of the list, but also on the values of the indices themselves, right? So
you stop when if you reach the end of one of the lists, you stop.
Yeah, but for example, what if in one list we have only 2 items, like 1 and 10, and in another list, okay, let's say not 1 and 10, 1 and 1,000,
Okay.
and in another list we have 1, 2, 3, 4, 5, 6, 7,
Until
etc.
1,000.
Until 1,000. Then we'll traverse the longer list, 1, 2, 3, 4, 5, and in a hope that we'll hit 1,000 in a longer list.
Yeah, that makes sense. So then I think the runtime should be the maximum of the 2. I mean, we have talked about this last time, right? The O of m plus n is the same as O of the maximum of m and n, right?
Yeah, that's correct.
Yeah, that's very good.
Yeah, then it's longer of the, yeah, that's a good observation.
So yeah, so that's a longer. Good.